graph inequalities and solve inequalities. But we first need to learn how to work with the notation. The first thing you need to understand is that math notation is always read from left to right. So when you look at the word read, R-E-A-D, we read it R first and D last. That's reading from left to right. If we go the other way, D-A-E-R, that's reading from the other way around, right to left, and that's not the way we read. So look at that first symbol at the top. The first symbol at the top, we're going to read it from left to right as well. So what we're going to do is look at the left-hand side, which has the open end, and that means greater than, and then the right-hand side means less than. So since we see the greater than side first, this is actually our greater than symbol. Now if we look at the next symbol is our less than symbol, and the reason it's our less than symbol is because the first part of it we get to is the teeny tiny part, and so that's our less than side, and we read that as less than. The following symbol is greater than or less than, and it's greater than or less than because you get to the greater than part first, and then so the next symbol is greater than or equal to. I just said that wrong a minute ago. It's greater than or equal to because it has the greater than sign first, and then it has the equal to underneath it. So the greater than side is the left side, so that's why we read it as greater than. And then the line underneath it means equal to. Now let's look at the next symbol. This one is less than or equal to because we get to less than first, and there's an equal to sign underneath it. And what does everybody think the next symbol is? Correct. The next symbol is not equal to, which is an equal sign with a slash to it. So the next thing we're going to do is practice reading. So we're going to read the next line together as a class. So go ahead and read that.
10 is greater than 4.
Very good. 10 is greater than 4. Now read the next line.
4 is less than 10.
4 is less than 10. Now notice they both mean the same thing. They're just written different ways. So now we're going to read the following. 5 is not equal to 6. The next one.
8 is greater or equal to 2.
Good. 8 is greater than or equal to 2. The next one.
6 is less than 11.
6 is less than 11. Correct. X is greater than negative 5. Now, in this statement, X is greater than negative 5, let's let X equal 7. Is this a true statement? Yes, 7 is greater than negative 5. If we let X equal 4, is that a true statement?
Yes.
Yes, 4 is greater than negative 5. If we let X equal 400, is that a true statement?
Yes.
Yes, 400 is greater than negative 5. If we let X equal negative 4, is that a true statement?
Yes.
Yes, negative 4 is greater than negative 5. And if we let X equal 100,000, is that a true statement?
Yes.
Yes, obviously, 100,000 is greater than negative 5. So what would be a statement that would not be true? If we let X equal negative 10, that would not be a true statement because negative 10 is not greater than negative 5. So negative 10 being greater than negative 5 is not true. But what is true for that statement? What would we write instead?
Negative 4 is greater than negative.
Right, we would write negative 5 is less than negative 10. That is a true statement.
Wait.
Oh, I'm sorry, that's the exact same thing. What would we write?
Negative 5 is greater than negative 10.
Negative 5 is greater than negative 10. Good. All right, when you're graphing inequalities, there are two things you have to think about. Open or closed circle, and which way does the arrow point when you graph. Now, we've seen with equations, all we do is we graph the equation by putting a closed circle on whatever our solution is. And that's very simple. There's no arrows or anything like that. It's just very simple. But it's a little different when we get to inequalities. With inequalities, we're not going to have just a regular equation. So inequalities, IN in the word inequality means not, so not equals. These are situations that are not equal, where the two sides of what would look like an equation are not actually equal to each other. So if we look at our greater than symbol, we'll see that that's going to be an open circle, because if I say that something's greater, if x is greater than 5, that means that any number that's bigger than 5 could be x. So I would not include 5 in that case. So I would use an open circle on my 5, and you'll see an example in a minute. And my arrow would point in the positive direction because all my numbers would be bigger than 5 to make this a true statement. Okay, so let's look at an example. Here we have x is greater than -5, so I would use an open circle on -5, and then I would have my arrow pointing in the positive direction. So let me explain what this means, because this is really, really the key to understanding open circles. If I look at -5 and -4, there are an infinite number of numbers between there. Let's think about it. We have -4.1 right in here, -4.11, -4.111111, -4.111111, and that goes on infinitely. We have -4.9, -4.99, -4.9999999. So we have an infinite number of decimals just between -4 and -5. So to demonstrate on a number line that I want to include all the numbers between -4 and -5, not including -5, I use an open circle on my -5. And what that is denoting is that any number bigger than -5, but infinitely close to -5 is a solution. In other words, any number that's bigger than -5 will make this a true statement. So the same goes for less than. Less than, because it does not have an equals, is not going to include your number. So if you have x is less than -2, we're going to put an open circle on -2, because -2 is not included. To make this a true statement, we pick any number that's smaller than -2, not including -2. And then all those numbers that are smaller are going to be on the left-hand side. So we'll have an arrow drawn on the left-hand side. Now, when we start using the next two symbols, notice that these have equals to in them. So since they have an equals to in them, you do use a closed circle. So if I said, for example, x is less than or equal to 3, I'm going to use a closed circle on 3, because 3 will make this a true statement, right? 3 does equal 3. I'm saying any number that is less than or equal to 3 will make this a true statement. So 3 is one of the numbers that's a solution to this that will make it a true statement. And then the numbers that are less than 3 are in the negative direction, or towards the left on my number line. So that's the way I draw my arrow. Now, in the next symbol, we have not equal to. With not equal to, we're saying if something is not equal, if x is not equal to some number, then x could be anything except that number. So that's actually an open circle on the number and then an arrow in both directions. So, for example, x not equal to 2, we'll have an open circle on 2 to say that x could be any number except 2. And then we draw the arrow in both directions to show all the other numbers besides 2. And then, of course, our last symbol we already know, and that's that when you have an equation, like x equals 4 in our first example here, we know to just put a closed circle on 4. And that's the only solution, is that one answer, 4. It's the solution, because 4 equals 4 is the only thing that can work, the only thing that makes that a true statement. So to recap, if you have an equals mark anywhere in your symbol, you're going to use a closed circle. If you don't have an equals mark anywhere in your symbol, you're going to use an open circle. And the not equals is the same as not having an equals mark. Think of it that way. If your inequality says greater than, you're going to be going in the greater than direction. If your inequality says less than, you'll be going in the less than or the small number direction. And if it says not equal to, it's going to be going in both directions except the number it's on. And if it says equal to, there's no line at all. In this first example, we have x is greater than or equal to negative 3. So we want to ask ourselves whether it's going to be an open or closed circle, and we then want to ask ourselves which direction the arrow is going to point. So in this case, it's going to be a closed circle because we have an equals as part of our notation. X is greater than or equal to negative 3. So that's why we have a closed circle. And then the arrow is going to point in the positive direction since it's greater than. In the next example, we have x is not equal to 3. And since it's not equal to, we're going to put an open circle. And then our arrow is going to go in both directions because we're saying that x could be anything except 3. In the next example, we have x less than 2, open or closed circle. Open on 2, since there's no equal to, and to go in the positive or negative direction. Right, it's going to go in the negative direction since it's less than. In the next example, open or closed circle. Good, closed if there's an equals to. That's going to go in the positive and negative direction. It's going to go in the positive direction since it's greater than. Okay, in the next example, is it going to be open or closed? Closed. Equal to. And positive or negative direction. Good, negative. Next example, open or closed circle. Open, because there's no equal to. Positive or negative direction. Positive. Go to the next example. Oh, we're done with our examples. Great. So now we're going to talk about solving inequalities. Solving inequalities is exactly like solving equations, except there's two things you have to keep in mind. The first, and this we have not talked about yet, is that whenever you multiply or divide both sides of an inequality by a negative, you have to flip the inequality. The reason that happens is when you multiply negative times a negative, you change the sign to what? A positive. If you multiply a positive times a negative, you change the sign to what? So because of the fact you're changing your sign, that's making the value either bigger or smaller, which means you're going to have to flip your inequality on your very last step. And we'll look at some examples. So that's a brand new thing we have to keep in mind. And then second, we have to graph a solution using the techniques we learned today. So let's do some examples. The first one's very basic. Here I'm going to start out by adding negative 4 to both sides as usual. Next, I'm going to multiply by the reciprocal on both sides as usual. Now, this is the step that